Okay, let's unpack something that's pretty foundational to our entire digital world, the database.
Right.
At its heart, it's a pretty simple idea, isn't it? Just a digital storage system. So software, like say Amazon or WhatsApp, can store and find information easily.
Exactly. And our goal today is really to track how that simple idea had to evolve. We're going to look at how these systems changed, not just for fun, but out of pure necessity to keep up with this explosion of users and data.
So where do we start? I'm guessing way back, maybe the 1970s.
Yep. The earliest real systems were called DBMS, Database Management Systems. Think of tools like DBase. They were basically a sophisticated file cabinet.
Just simple file-based storage.
Yeah.
Functional, but I'm guessing they had some major limits.
The critical one, they couldn't really create relationships between data, and they definitely couldn't handle a lot of people using them at the same time. You couldn't, for instance, easily link a customer record to an order record.
Which feels like a pretty basic thing you'd want to do.
It is now, yeah.
So that limitation brings us to the 90s and RDBMS, the relational database.
It's a relational model, right? This is the huge shift. Now, data is organized into structured tables, rows and columns like a spreadsheet. But the key is that these tables can be linked together.
And that relational part was crucial for things like banking, right? Would that guarantee?
It guarantees what we call ACD properties. It's an acronym for atomicity, consistency, isolation, and durability.
Okay.
It's the bedrock of transactional stability. In a bank transfer, you need to know that if the process fails halfway, the entire thing rolls back. Your money isn't just lost in the ether.
Ah, I see. So it's all or nothing. And systems like MySQL and PostgreSQL still do that today.
They do. They're incredibly popular because they enforce that strictness.
But that stability sounds perfect. So why did we need anything else? Then Facebook happens, massive e-commerce sites pop up. Did RDBMS just get too slow?
It wasn't just about speed. The core problem was rigidity. Imagine trying to add one new field, just one, to a table with a billion rows. With all those interconnected tables, an RDBMS has to do a ton of coordination. It just doesn't scale well horizontally.
And that's what kicked off NoSQL around 2008.
Exactly.
So NoSQL, which means not only SQL, it's all about flexibility then. Instead of those rigid tables, you get something more like a flexible JSON document.
That's a great way to put it. But if you're giving up that rigid structure, you must be trading something away. Are they less trustworthy?
That is the core trade-off. You sacrifice some of that absolute ACID consistency for incredible speed and scalability. Okay, so for a social media feed, you care more about speed than if every single like is perfectly consistent across the globe at the exact same millisecond.
Precisely. You see that in document databases like MongoDB or key-value stores like Redis. They are built for massive traffic.
Okay, so that covers application data. But what about the truly huge stuff? The petabytes of data companies use for analytics or training AI models. That's a different problem entirely.
It's a completely different beast, yeah. We're moving from storing transactional data to processing analytical data. That's the world of big data tech, like Hadoop and Apache Spark.
They're not for running your app, they're for crunching numbers after the fact.
Right. They process massive historical data sets to find insights.
And bringing this all into the modern day, the biggest trend seems to be cloud databases. Why should we care if our data is on AWS DynamoDB versus a server in a company's basement?
It's a game changer because it completely abstracts away the physical hardware.
So no more maintaining servers.
None. You get services from AWS or Google Cloud that auto-scale. They grow as you grow, and you only pay for what you use. It's the ultimate answer to unpredictable scale.
So if we pull back, it seems like we have a few clear categories today. RDBMS for stable transactions like finance, NoSQL for flexible, high-speed modern apps, and big data systems for massive scale analytics.
That's a perfect summary, which, it leaves you with a really interesting question. The shift from RDBMS to NoSQL was driven by the scale of social media. So what's the next big data challenge that will force another fundamental shift in how we think about databases? Maybe something with real-time data or even quantum computing.
Something for us all to think about.
Yeah.